Number 17, an investigator suspects that the proportion P of MTSU students that own a computer is close to 0.4. What sample size is needed to find an interval estimate of P that has a 0.03 margin of error and a 95% confidence level? And it wants us to use 0.4 as a preliminary estimate of P. Perhaps from a survey or something like that in the past. Let's go ahead and do this. So this is one of the few formulas we actually need to know, and definitely put this on your note card. It's n equals z alpha over 2 times sigma all over e and square it. Okay, and so we have all our values here. So 95%, do you remember what that corresponds to? Let me turn my writing on. So let's recall what this means. So if it's 90%, that means there's 10% for both tails, right? So that means we have 5% in each tail. So the left in each tail is 0.05, because remember it's divided by 2 right here. And so what would our critical value be? So our critical value. I did a whole video on this several weeks ago. The critical value here is going to be 1.645. So you can put that on the note card or just remember it. Or let me show you how to, if you don't want to do that, this is kind of what I would probably do, is let's do this on the calculator. How do we figure that out? Remember what we're doing mathematically is we're trying to find, let me draw this out. So if this is 90%, I'll just show you this on one of them and you can do it for the other ones. That means we have 5% in this tail, 5% in this tail. So if that's 0.05, how do I find, remember that's 0, right? How do I find this value here for z? I use the inverse norm, right? And so I'm going to second distribution, inverse norm, and we can put in 0.05. Now it's going to spit out the negative, but we're going to always use the positive. So the critical value 1.645. You can do the same thing for 95% and 99%. So for 95%, the alpha over 2, the percent left in each tail, 0.025, right? 0.05 divided by 2. Its critical value is about 1.96. Close to 2. And then 99%, 0.005. And that's pretty close to 2.575. And so you can put this on your note card if you want. You really don't need this part here. Hopefully you know how to do that. But make sure you can, if it asks for 90%, we'll use this one, 95%, 1.96, 99%, 2.575. It's actually pretty closer to 2.576, but that's okay. So ours that we're looking at is this one right here. So we are looking at RZ alpha over 2 is 1.96. Okay, so we have our Z alpha over 2. Now about sigma, in fact, I hope I don't confuse you here. There are two formulas. We have one for n when we have means. And we have one for n when we have proportions. And this is the one here for proportions. So we use this one when we're talking about means. So this one here is for means, and this guy here is for proportions. Okay, so when we're talking about proportions, you start seeing proportions or percent. This is here is the one we're going to use. We're talking about p hat, sample proportions, right? So our preliminary estimate of p is 0.4, so that goes in for p hat here. So we are not going to use this one for this particular one, but you can imagine just because I gave you, this is given, I didn't give it to, but just because this one's given on the review, you always need to think, what else could they have asked that's maybe not on the review? I mean, if we put every possible problem on there, the review would have 300 questions on it, and we don't want to do that to you. So you need to kind of do this to yourself, right? Say, could I do the one that has means? And would that shake me at all? Hopefully not. They will generally give you that standard deviation. Okay, here we're going to be at p hat times 1 minus p hat. So in our case, our n is going to be 0.4 times 1 minus 0.4 times the z alpha 2 is still the same as it was with means as it is proportions, and that was with 95%, remember, was 1.96. My points don't show up sometimes. Divided by the error. Now let's see what they say. Margin of error here is 0.03. So 0.03 squared. Okay. Now once we do that, let's go ahead and pop it in. So we're going to do 0.4 times, we could just do 0.6, but sometimes they get a little trickier to do in your head. 1 minus 0.4 times, I'm going to do 1.96 divided by 0.03, and don't forget to square it. I sometimes forget to do that. Make sure you don't do that. Then we get 1024.4. Now, if you recall on this, we always round up, no matter what this number is. If it's 0.01, we always round up to the next integer. So 1025. Now, luckily, they didn't have the attractive distractor 1024 on here, but there we go, 1025. See. Hope that helps.